All right, so this is 2000, number 5, no calculator. Consider the curve given by xy squared minus x cubed y equals 6. Show that the derivative is that. All right, I would start by just doing implicit differentiation. The first step I would do with respect to x, so I'd write y squared minus 2xy, y prime, minus, and again, I would do x, so I would get 3x squared y minus, and this is where you got to be really careful because that negative will distribute to the differentiation, and you're going to get x cubed y prime equals 0. So we do this implicitly. All right, and then we just got to solve for y prime. And there's a bunch of ways to do it. And the thing you want to catch, if you can, at this point, is you definitely want to move y squared and this, because if you look at the derivative they have, it was negative y squared. And you want to get the sign. There's no reason to double back. It takes 1 second to glance at it and send those back into the other side. Oh, I made a mistake here. That should be plus, shouldn't it? And then send the other to the other side, and I get 3x squared y minus y squared, which is the numerator. And if it says show, I would write all these steps, all right? And it was worth 2 points. It was worth 1 point for the differentiation, and believe it or not, 1 point that you wrote this, which I would write dy dx, because it asked for dy dx. I wouldn't use y prime. You should get a point either way, but I want to match. All right. So 2 points. Now we got to be thinking, if this is implicit differentiation, what do you think you're going to have to do with it? Eventually, you're probably going to have to. Yep. We will. Let's do part B. All right. So the second one, just find all points in the curve whose x-coordinate is 1, and write the equation of the tangent line of each of them. So if I have x is 1, if I want to draw a tangent line, I need a slope and a point. I have the derivative, so let's get the points first. All right. So I'll plug 1 into the original equation. 1 times y squared is y squared. 1 cubed is 1 minus y equals 6. Do not complete the square. Do not enter in your calculator. See if the thing, well, you can't enter in the calculator, it's 5. This thing factors. Oh, man. It factors beautifully. So one answer is 3. The other answer is -2. So that you had, believe it or not, this equation is worth a point. Y squared minus y equals 6. You have that, give yourself a point. All right. So if you have that on your, give yourself a point for that. And if you solve for y and get 3 and -2, all right.
Oh, we actually had to write down what they equal. We couldn't just.
Well, you're going to have to, because you got to get 2 tangent lines. You're going to have both points.
Right. But I mean, I just left it in the form above the y equals and y equals.
Well, somewhere you're going to have to write this, because you're going to have to get 2 tangent lines, and they're going to be different. All right. So the tangent lines here, you got 1 for 1, 3, right, and 1 for 1, -2. So I would do the derivative y prime equals, and again, you have to plug 1, 3 into this. Do we agree? So we plug in 1 and 3, and I get 3 times 1 squared 3 minus 3 squared. A equals 0 on top. Just got to make sure it doesn't equal 0 on the bottom. Do we agree? And it doesn't. Do we agree? So y prime is 0. So we have.
Do you have to y prime at?
Oh, at point. It's not a bad idea, but I'm going to leave it because I did it under this section. And the equation of my tangent line at this point, I'm doing a different color. Well, if y prime is 0, it's just y equals -1, or 1. Do you guys agree? Tangent line is y equals 1.
Don't you mean -3 or 3?
Well, I mean 3. I'm sorry. Well, that would have been a bad.
3 equals 0.
Yeah, you could. And shoot, there's a case of not thinking. Just do the darn equation. Y minus 3 equals 0 times x minus 1. All right. So there's a tangent line. At 1, -2, you got to plug in same thing. And I kind of lost it here, but y prime equals 3 times 1
equals 2.
Huh? It equals
2.
2. I agree. All right, I'll be done in just 2 seconds. We'll cut on this and just hang with me. What's for lunch today?
No idea.
Nothing good then. You can wait for it. All right. And I will do part C as the video. But listen, we do this, and you get y prime equals 2. And again, I'm not going to make the same mistake twice. I'm going to write y plus 2 equals 2 times x minus 1 point slope form. So final points, and write an equation with tangent line. I would leave it in this tangent thing. So here's a point, here's a point, or here's a point. And then we already agreed points were for this format right here, and for these three inches here, 4 points. So think about it. This is a 6-point answer. I mean, it's a 9-point problem. These 6 are really easy. Now, there's a note here that says you get 0 for 4 if you didn't have this somewhere in your thing. Now, so even if somehow you came up with the right answers, if that wasn't on there, if not solving an equation of the form y squared minus y equals k, say you screwed the math up, if you didn't have this, you got no points. Okay? Because they didn't want you going down the disaster path. All right. So find the x-coordinate, part C. Find the x-coordinate of each point on the curve where the tangent line is vertical. Tangent line is vertical when the slope is undefined. So we got to find when this thing's undefined, which means we need to find one line. And I bet you this is a point. Just writing that down. Yep, that's a point. Setting the denominator of dy dx to 0. That's a point in this problem. All right, I have to solve this. You've got to see that you get this. So I know one answer is x equals 0, or and 2y minus x squared equals 0. So we got one answer at x equals 0, or that equation. Once you solve this, move x squared over and divide by 2. You guys agree to get y equals 1/2 x squared? That parabola, every point on that parabola, all right, that's going to be places where the 0, where it crosses on the other curve. So first thing we got to do is notice that at x equals 0, we go up and we check the original curve. We check the curve, and 0 is not in the domain. Function doesn't exist there. Do you agree? If you look at this up here, and you can't put 0 and you can't get a y value, right? So it's just undefined there. So we don't have to worry about the 0 point. So because 0 is not in the domain, thus it can't be in the derivative domain. All right. But when we have y equals x squared, we're going to have to go back to the original function, which I write here in green. And look how pretty this is going to be. They make these pretty on purpose. I'm going to plug in 1/2 x squared for y. Do just a substitution. And when I do this, I'm going to get x to the 5th on both of these. I'm going to get 1/4 x to the 5th minus 1/2 x to the 5th equals 6. So I can, like terms, negative 1/4 x to the 5th equals 6. So I get x to the 5th equals negative 24. Take the 5th root, and since it's an odd root, we can do this, right? So x is the 5th root of negative 24. It's some decimal, but we don't have a calculator, so that's what we're going to leave it as. And that's the x coordinate. So listen, there's a point that you substitute in here is a point, and I already said that the third point was setting the derivative equal to 0, and that's the answer for this one. Pretty straightforward. X is that coordinate.